Hello students, today I'm going to be telling you about how to find distance in a coordinate plane. I'm Mrs. Daywald and I will be your teacher for the day. The first definition I want to underscore is when a point is reflected across an axis. When a point is reflected across an axis, that simply means that that point is equidistant from that axis. So here we have the x-axis going vertically and the y-axis going horizontally. If I had a random point at, say, 4, positive 2. So my point is 4, 2. That's my ordered pair. That's the location of my point. And it was reflected across the y-axis. That would mean it would be equidistant from the y-axis. So this point is 1, 2, 3, 4 units from the y-axis. So a reflected point would have to be 4 units in the opposite direction. 1, 2, 3, 4. And that would be a reflected point. It's the same distance from the y-axis, reflected across the y-axis. And the ordered pair at this point would be negative 4, positive 2. Notice, it's reflected across the y-axis. So in each of these ordered pairs, the y-coordinate is the same. The x-coordinate, on the other hand, is the opposite. Negative 4 and 4 are opposites. So that's how you would know if a point was reflected across the y-axis. Similarly, if a point is reflected across the x-axis, if I had a point at negative 2, 1, the ordered pair is negative 2, 1, the point would be at this position. I'm going to make that point red. Now it's going to be reflected across the x-axis, so that means it's going to be equidistant from the x-axis, the same number of units away. It's 1 unit away from the x-axis in this direction, so it has to be 1 unit away in the other direction. The ordered pair of that point would then be negative 2, negative 1. Notice it's reflected across the x-axis, so the x-coordinate is the same, negative 2, and the y-coordinate is the opposite. 1 and negative 1 are opposites. Also, they would not be in the same quadrant. Recall that this is quadrant 1. Going counterclockwise, we have quadrant 2, quadrant 3, and finally quadrant 4. Let me rewrite that. Quadrant 4. And we usually use Roman numerals in order to identify the quadrants. Going back, let's do a practice. Without actually plotting the points, what would I need to do? If I have a point at 3, negative 2, and it's reflected across the y-axis, remember, the y-coordinate would be the same, negative 2. And the x-coordinate would be the opposite of 3, and the opposite of 3, negative 3. Similarly, if it's reflected across the x-axis, the x-coordinate would be 3, and the y-coordinate would be the opposite. It was negative 2, now it's going to be positive 2. What I'd like you to do is I would like you to take a second, I would like you to pause this video, and then I would like you to practice the following points. If I were to give you some points at 3, 5, and I would give you another point at negative 2, 6, and lastly a point at negative 3, 8. I'd like you to try it and see if you can do them on your own. Remember, if it's across the y-axis, the y-coordinate's the same, and the x is the opposite. If it's across the x-axis, the x-coordinate is the same, and the y would be the opposite. Try it on your own.